Hello everyone, my name is Michael Bosniak. I'm a MuleSoft technical architect at Salesforce. Today I'm excited to share a demo that I've built using the MAC project. MAC in short stands for MuleSoft AI Chain. It's an initiative that started roughly 3 months ago, designed to bring advanced AI capabilities into the MuleSoft ecosystem through multiple connectors. One of these connectors is the MuleSoft AI Chain Connector, which I used to create a demo focused on retrieval augmented generation. A RAG operation, simply explained, involves enhancing the response generation of a large language model by allowing it to retrieve information from a local knowledge store or external sources that the LLM usually has no access to. And my motivation behind this project was not simply to build a demo, but a project that I would use personally. So basically my own AI assistant or chatbot that is capable of accessing and retrieving information from my own local knowledge store on the fly. This would allow me to quickly access the exact information that I need from a central knowledge store, making my work much more efficient and productive. So instead of manually going through my documents, trying to find a specific document that I need, I would simply ask my personal chatbot a question and it would retrieve the answer from my local knowledge store in no time. So without further ado, let's jump directly into the demo. All right, let's come to the demo. So what you can see here is the front end, which I have built using Next.js. So it's a React framework and it contains only 3 components that I need for the whole RAG flow. So that means creating a store, uploading a document, and retrieving information from that knowledge store. So that's basically the UI. Then I have also the backend, which is based on MuleSoft. So in Anypoint Studio, I have configured a MuleSoft application with 3 endpoints that do the hard work for me of creating the store, parsing the document, creating chunks of it, and even creating all the vectors and embedding them into the vector store. And of course, then also I have a dedicated flow in my MuleSoft application that will retrieve the information. First, I will show you the UI, and after that, I will switch to the MuleSoft application. So let's start with Create Store. With Create Store, I can create any store anywhere. So in my case, I have configured the MuleSoft AI Chain Connector to create a store locally on my machine in a specific folder on my desktop. Let's start by just creating a store. I will call it Matrix 5, like the Matrix movie. Okay, now it has successfully created a store. So if I go here, you can see that there is a file that has been created, which has 0 entries. Okay, so the file is very small, I think only 14 bytes of size. So nothing is in there, but I have created already a first vector store using the MuleSoft AI Chain Connector on my local machine. I will skip the part where I will upload the document just to show you how this works and what the benefits are of having your own knowledge store. So if I now pick this store matrix that I've created, I can now ask my chatbot a question. I can ask, for example, what is the story behind Matrix 5? Matrix 5 is a movie that has not been released yet. I'm not even sure if this movie is planned. We know that the last movie was Matrix 4. It has been released 3 years ago, and I think it's called Matrix Resurrections. So there is no Matrix 5 movie yet. So if I ask the LLM a question, so if I say LLM, I have now configured the connector to use the Model 4.0 from OpenAI, but we support multiple large language models. As you can see here, the LLM responded correctly, so there is no knowledge yet on the movie Matrix 5. The last knowledge cutoff date of the LLM was October 2023. So there is no information available yet about this movie. What I can do now is, because I've prepared a couple of documents, I've just made up a story about Matrix 5. Created 3 markdown files. One markdown file is called Matrix 5 Introduction, where I just simply introduce this made up story about Matrix 5. Okay, I will now add it to the Matrix store, upload document, and now I can see that the document has successfully has been successfully been embedded into my knowledge store. And if I click again on my knowledge store called Matrix, you can see that I have a first entry here with an ID and even the text. Okay, so basically the document that I've provided and the vector. So the vector is nothing else than a mathematical representation of the text itself that I have uploaded. And everything has been done out of the box using the MuleSoft AI Chain Connector, which includes a lightweight embedding model. So now I will use or ask the same question again. What is the story behind Matrix 5? So now the LLM should have access to my knowledge store because I have added this document, and it has successfully found this information, retrieved it, and returned a summary about the movie called The Code of the Omniverse, and it even included the evidence that it has found. So basically my file which I've uploaded, which was called Matrix 5 Intro as Markdown file, with some additional metadata like the store name where the information has been saved. Okay, so that means this knowledge store works very well end to end. I can now add multiple information. I can now even say, okay, let's some additional information about the ending about the movie. Okay, I've also created a new file, also again made up story about the ending of Matrix 5. Let me upload it. So the same process again. And then I can ask a question, what happens at the end of the movie Matrix 5? Okay, and then let's see, okay, it can find information at the end of the Matrix movie, blah, 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 blah. So we have a nice summary, we know exactly what happens. Again, evidence has been provided with the new file that has been added, and in what store this information has been stored. So from an end-to-end perspective, works really nice. That was the front end. And let me show you what happens under the hood with our MuleSoft application. Okay, let's come to the last part of this demo. What you can see here is Anypoint Studio and the MuleSoft application that did everything under the hood. Okay, it's really simple. As you can see, it just contains 3 flows, and that's it. This took me really 15 minutes to build, not longer, of course, because it's really simple and I have not added any best practices like error handling, or I have not added an API specification, which you should do. That's best practice. But for this really simplified use case of creating my own knowledge store that runs locally, this is definitely enough. So 15 minutes and it's running perfectly fine. The whole front end, of course, took me longer because you have to write code, you have to create your own chatbot, you have to make it responsive. You don't have to, you can. But this took me maybe 2 days, okay? So let me explain you how those flows work in Anypoint Studio and what exactly the individual operations are doing. Before I do that, you can see here that I have added the MuleSoft AI Chain Connector as a module in my project. I'm using the recent version, which is 0.229 snapshot, currently on our develop branch. And we support today up to 16 individual operations. A lot of operations will also come into the future. We are constantly optimizing them. So we have agent, chat operations, multiple embedding operations, image read, image generate. We have a dedicated rag load document operation. That's not the one that I use today. I have used the embedding operations to have my own persistent knowledge store. This is not possible with rag load document because you need to provide a document with each request, okay? But I wanted to have a persistent knowledge store, and that's why I used 3 embedding models that I will explain you now in the next step. All operations have been documented on our website, which is mac-project.ai. You can go to /docs and you will see an introduction of this connector, but also an introduction to the upcoming connectors. Every single operation is described with a screenshot with example configurations, and we also have a lot of demos provided here in the showcase section, so please check them out. And if you have any questions, if something is not clear, just contact us through the contact form. Okay, so let's continue with the MuleSoft application. The very first flow contains the embedding new store operation. It's really simple. You can see I just need to provide one single input. I don't need to even configure the connector because I just need to provide the store name. That's it. I have added here also a path because I wanted the store name to be created on my desktop in this dedicated folder so that I can check out its content, and it helps me a little bit for debugging. But of course, you can also remove the path, deploy to CloudHub, and the files will be stored within your MuleSoft application on CloudHub, and you will also have this kind of persistency layer there. Every time you restart your application, the file will still be there. But of course, in future, we will also add in-memory capabilities so that, for example, you can just restart your application and the knowledge store will be refreshed. Okay, so that's the very first step, creating a store which is exposed on port 8081 and I think on the path/store. Then I have the second flow, that's for uploading documents, this one. This requires a little some more inputs, but still I do not need to configure the connector. I do not need any LLM configurations because everything works out of the box with the connector with its own lightweight embedding model that has been added. Okay, so I have a store name, the same store name that I have created in step 1. I need to provide a file path where my file is being stored so that the connector can parse the file and chunk it. This brings me to the next two parameters that you need to provide. That's max segment size in chars and max overlap. And this is basically the chunk size and the chunk overlap. So every time you add a document, you need to play around with your chunk size. In my case, I have a chunk size of 1500 characters. The smaller, the better, because smaller chunk sizes are more efficient when it comes to retrieving information, when it comes to processing time, but also when it comes to making sure that the LLM can respond with the exact information that you really want to see. If you have a large chunk size, this will slow down the process, but it will also be hard for the LLM to identify what piece of information you are exactly looking for. But of course, the chunk size should also not be too small. And we have also the file type parameter, which at the moment supported our PDF, text, and we have URL as well. Okay, so that's my second flow. As you can see, really simple. And the last one is about retrieving documents. Here I have configured the connector because I had to provide additional information. You can see that I'm using the LLM type OpenAI, but we support multiple LLMs. We also have Anthropic, Azure OpenAI, Mistral, Olama, a local one if you want to use a local language model, for example, with some additional configurations here. I will not go into the details because every configuration step here is also described in our documentation. If you go to docs and get started, everything is documented. How to add the application to the MuleSoft, to Anypoint Studio, how to install it locally first, how to configure it, how to provide the configuration information, like for example, because I'm using OpenAI, I need to provide an OpenAI key, of course, okay, which I have added here in my config.json. So let's continue with the last flow. As you can see, I have provided an LLM. I need to provide, of course, a prompt, which will be my question, and the store name where I want to retrieve my information from. And that's already it. This works really nice end-to-end if you want to use an LLM. But we also have another additional operation called embedding get a query from store. This one works. I will not drag it now. I can drag it into the canvas, no problem. This one works, as you can see, without an LLM because the connector already includes an out-of-the-box embedding model, but it is not as powerful as a dedicated one, like for example, the one from OpenAI. If you use this one, then your query will be based on text only. There will be no model that will try to understand the context of your question in order to make sure that it retrieves the exact information that you're looking for. If you use this operation query from store, then it will do a really basic search based on text instead of based on context. If you want to have a query based on context with the help of an LLM, then you should use embedding get info from store. Okay, so that's the MuleSoft application. What I will do is I will add it to our GitHub repository, including the front end application, play around, let me know what you think. If you identify, if you see some bugs, some improvements, let us know. And yeah, that was it. I hope you had fun and see you hopefully in the next demo.